Hi and welcome back to another demo of the UK electrical simulator. In this video we are not going to build a full circuit, instead we are going to focus on wires, resistance, testing links, connectors and also introduce the Megga Meter. Let's begin by adding a testing link and the connector to the workspace. If we double-click the testing link, you will see the terminal orientation change. This can be useful when you want the component to sit more neatly within the layout. We can also double-click on a connector to rename it. For this example, I'll change the label to a single full stop, just to hide the name for now. We'll come back to the importance of connectors in a separate video. For this demo, we are going to need several testing links and connectors. Rather than placing everyone manually, I am going to save time by opening a pre-saved workspace. To do that, go to File, then choose Open Saved Workspace, select the correct file, and the prepared layout will appear. Before we begin testing, let's activate the selected wire window by placing a tick in the option. Let's now start adding wires between the various terminals and changing their sizes. We'll add the first wire across the top components and leave its settings as they are. Next, we'll add another wire, but this time change it to blue with a CSA of 2.5. Then we'll add another wire and change that to a CSA of 4. We'll add another wire, this time red, with a CSA of 6. You may already be starting to notice a pattern here. As the CSA increases, the wire becomes visibly wider on the workspace. This is a very useful visual feature because it helps distinguish different cable sizes more easily while building or reviewing a layout. Let's continue by adding another wire in green and yellow with a CSA of 10 and then a final wire with a CSA of 16. For completeness, we can also add 2 more wires. One will have a length of 5 meters and a CSA of 25, and the other will have a length of 10 meters and a CSA of 35. At this point, we can now clearly see the different CSA sizes of wire and how they are represented on the workspace. The next step is to measure the resistance of an individual wire. To do that, we need to add a Megga Meter to the workspace. This is the first time we have used the Megga Meter in these demos, so this is a good point to give a quick overview of how it works. You can add multiple Megga Meters to the workspace, and each one is given its own unique name, such as Meter 1, Meter 2, Meter 3, etc. We only need one meter for this demo. The Megga Meter includes several functions, with more planned for future releases. At the moment, the top drop-down gives you the options voltage, current, resistance, insulation and loop. For this demo, we are going to select resistance. We will look at the other functions in separate demos and training videos. Once resistance is selected, you will see several buttons, the meter display, and a second drop-down box. This second drop-down gives 3 options. The first is network, which measures resistance from one terminal to another and takes account of series and parallel paths along the route. The other 2 options measure only the shortest continuity path. For this test, we are going to choose Network, then press the Probe A and Probe B buttons. This will place 2 probes onto the workspace, labelled 1A and 1B. If we had added a second meter, the probes would be labelled 2A and 2B, and so on. These probes are used in the same way as in the real world, by connecting them to 2 separate points in order to take a measurement. The difference here is that in the simulator, there are no loose meter leads getting in the way. We simply connect each probe to the terminal we want, and a green LED appears on both the probe and the meter to show that the connection has been made successfully. You can also double-click the probes to change their orientation, which is useful when terminals are close together and you want to keep the layout clear. Let's now measure our first wire. Connect one probe to the terminal at one end of the wire and the other probe to the terminal at the opposite end. Once both probes are connected, the test button will turn green, prompting you to press it. When pressed, the display will show a reading of 0.005 ohms. We can verify that reading by opening the resistance table from the Resources drop-down menu. This table shows a range of resistance values based on wire length and CSA. From the selected wire window, we already know that this wire is 10 meters long and has a CSA of 35. So, if we cross-reference those values in the table by finding 10 meters across the top row and 35 CSA down the left-hand column, we get a value of 0.00524 ohms. That matches the reading on the meter, rounded to 3 decimal places. This gives us confidence that the simulator is calculating the resistance correctly. The aim is to keep these demo videos short, clear, and to the point. And unfortunately, we have run out of time for this one. In a future training video, we will come back to this topic and take a closer look at series and parallel resistance and how those values change within a circuit. Please like, subscribe, and leave a comment below. I'd genuinely love to hear your thoughts, especially if you feel this kind of tool would be useful in supporting your training journey towards becoming a UK electrician.